Good day, ladies and gentlemen. It's Mr. Nambane again, and welcome to my channel, Nambane Academy, the Institute for Math and Science. Thank you very much for the support you've given us, and thank you very much for sharing the links. The numbers are growing, so it means definitely you're enjoying the content that we are sharing with you. So now we are busy with organic chemistry. So we have a series of videos that we did under organic chemistry, especially for grade 12. We did naming and structures. I think we have about 2 videos there. We recently did one on physical and chemical properties. So today the idea is to do a part 2 video for physical and chemical properties. But now the approach is we are going to look into how graphs are being assessed, or the topic itself in terms of the graphs, because other questions that I've seen before, they are generally standard questions that each and every one of us should be able to get maximum marks. But because graphs are a new trend, that's the reason why we sat down with the team and decided that now we need to look into how best can we assist you in terms of interpretation of graphs as well as answering accordingly. So without wasting any time, let me get straight into this question. I think it was one of November papers, but we will look into it and then try to explain everything in detail. So what is our approach in terms of getting the questions correct? The first thing that we do is we look at what is the total for the paper. At the very same time, we also look for level 1 type of questions. So level 1 type of questions will be my definitions and the reasoning that is somehow related to the definition. So already it says to me, I am in a position of getting about 3 marks already. But now for me to understand fully or in detail, it means now I must read my stem and my question and exactly analyze what the graph it says. So I'm going to read this again. The vapor pressure versus temperature graph below was obtained for 4 chain unbranched alkanes. So basically we are working with single bonds because we are told that it's alkanes. Can we further extend it? Yeah, we can extend it that now if all of them are unbranched, so the factor that we are looking for, or the factor that will be assessed now, is the chain length. So already from reading the stem, I'm able to automatically pick up what is it that the examiner is going to ask me about. Already, whatever I say now, I can be able to relate it now to chain length as well as the single bonds. So once I have single bonds, what else can I say? I definitely know that I must have now a London forces because it's single bonds. So all this, it's me trying to understand the question before I can even try and attempt to answer this particular question. But the further goes on and say from P to S, each compound differs from the previous compound by a CH2 minus group. The vapor pressure is measured in mmHg, and then the atmospheric pressure at 760 mmHg, millimeters mercury. So now, what does this necessarily mean? Remember, we said for us to talk of boiling point, we said boiling point is defined as the temperature at which the vapor pressure is now equal to the atmospheric pressure. Now, with this being said, it says to me, if this is my atmospheric pressure here, then the temperature that corresponds with that, this atmospheric pressure will give me now my boiling point. So it basically says, if I want the boiling point of compound P, then I am going to measure between compound P and the temperature. So this here will be the boiling point of compound P. But further on, if I want the boiling point of Q, it must be a point where there's an interaction, or the graph intersects the y-axis as well as the x-axis. Then for compound R, it will be at this point and then at that particular point. So now for S, it means we still have a long way to go before we can reach the boiling point, because remember, it will only start boiling once it touches 760 mmGH. So it means now this one already, because of it's not now reaching 760 at 100, so it means it's now having the strongest intermolecular forces. So this one has the strongest intermolecular forces, because now it is not even reaching 760 at 100. So S is the one that has now the strongest intermolecular forces. So what does that mean in terms of strongest intermolecular forces? It means now compound S also must be the longest in terms of chain length. So definitely, so we will look into that and then explain it further. But remember, this is a graph of vapor pressure versus temperature. So I'm going to try and now answer questions because the illustration has been made. So answering questions, let me just duplicate this. And then I will be able to clear this up. Then we can be able to start looking into it. So 3.1, all of us must be able to get a maximum marks. The question there is, give a reason why alkanes are said to be unsaturated. It's easy. They contain, or they have single bonds, and then others it's they have no double or triple bond. They have no double or triple bonds. In case others, we say now no multiple bonds. It's important also to emphasize where this multiple bonds, no multiple bonds between carbon-carbon atom, between carbon-carbon atoms. So that is very, very important. So they have only, it's very key also, only the single bonds. So with that, we'll get just 1 mark. Then at 3.2, 3.2, define the term vapor pressure. We did explain in our previous video that whenever we are given a definition, we must use the definition as it appears in the formula sheet, not in the formula sheet, but in terms and definitions. So the correct definition here is the pressure exerted by a vapor in equilibrium with its liquid in a closed system. I usually say definitions are 2 or 0, so you'll get a 2 for that. Remember, it's a definition 2 or 0. And like I did say, this definition of a vapor pressure is a definition that us as students or learners, we usually get it wrong. So for that fact, the examiners are asking this a couple of times. So be ready, know it, and prepare yourself accordingly. Now at 3.3, and then 3.31, they are saying now use the information in the graph above to answer the following questions. What is the effect of an increase in temperature on vapor pressure? Choose from increase, decrease, or no effect. So now, what we know about increase in temperature is that increase in temperature also increases the vapor pressure. So the correct answer here should be increase. So the correct answer is increase. Then we get another 1 mark. Then we are in the right direction of getting things right. Then we further move on to 3.32. Which compound has a boiling point of approximately 68 degrees Celsius? Give a reason for your answer. So I did explain that when we look into our graph here, the only way we can get the 60 is if we look, the 68 is if we look between now 760 as well as the corresponding temperature. So if we have 68 degrees Celsius here, remember we must also look now that where is the intersection between the temperature and the vapor pressure. That is now equal to the atmospheric pressure. That's the reason why the correct answer here should be Q. Then they say now give a reason for your answer, and then the reason for the answer is it is the temperature. Okay, it is the temperature. It is the temperature. It is the temperature where the vapor pressure equals the atmospheric pressure. That is only when we get to a point of boiling point, to the atmospheric pressure. So let's understand that it is quite important. So organic molecules will only start boiling once the temperature or the vapor pressure is equals to the atmospheric pressure. But now at that specific temperature. So you'll get the 1 for saying the correct answer is Q, and then you can all easily get 1 for giving the correct definition. Then it becomes a nice 2 marks. So if you check this question, already we are comparing alkanes, but when we compare alkanes, we said it's either we look into the chain length as well as the number of branching, because the homologous series is the same throughout. So this says to us now, it is important first to identify and analyze exactly what is it that the examiner is asking us. So in this case, the examiner was assessing us in terms of chain length, but now moving from vapor pressure, also including factors or issues of boiling point. So now we have exhausted 3.32. I feel that we understand what is expected from us. So we will go to 3.3. Let's go to 3.3. Which compound has the longest chain length? Fully explain your answer. I think we have already done that by the fact that we're able to identify which one has the strongest intermolecular forces. So we are able to do that already. So I'm going to create space here so that now we can answer 3.33. So now at 3.33, the correct answer, we did say it should be S. Now, why is S correct? We explained that S takes time before it reaches the 760 mmg mark. So it basically says now it has now the strongest intermolecular forces. So how do we relate now the intermolecular forces with chain length? We know that the longer the chain length, the stronger the intermolecular forces. So we can easily say now, let's explain this in terms of the bullets that we are expected to give. So we will be able to say the first one is at a given temperature, S has the lowest vapor pressure. So we easily say S has the lowest vapor pressure, meaning higher boiling point, meaning higher boiling point. That is key. So now that we know that S has a lowest vapor pressure, that has now meaning it has a higher boiling point. We definitely know what to say in terms of the strength of the intermolecular forces. So we'll easily say S has stronger London forces than P, Q, and R, than P, Q, and R, which is true. Then it says now the last bullet will be energy. We need now what? More energy to overcome the intermolecular forces. So more energy is needed to overcome the intermolecular forces of S, then that is how you will be able to get your maximum of 4 marks. Has the lowest vapor pressure, stronger intermolecular forces, more energy. Comparison of the strength in terms of the structure as well, but now because we're given a graph, we can easily relate that to the vapor pressure. Then the energy, so we'll get our maximum of 4 marks. So this is a nice way of understanding the graph. So we are moving from what we are confident with, because majority of us are confident in terms of explaining in terms of boiling point. Hence the emphasis here was, of course, if S has the lowest vapor pressure, then it means we have a higher boiling point. So if we have a higher boiling point, it means now S must have stronger London forces than P, Q, and R. Then definitely more energy is needed to overcome the intermolecular forces of S. Let's look at 3.4. A 3.4 compound P has 5 carbon atoms. Draw the structural formula of a chain isomer of compound P. Write down the IUPAC name of this isomer. We said an isomer, compounds with the same molecular formula but different structural formula. So if we know that it has 5 carbons, its straight chain will be 1, 2, 3, 4, 5. Then everything here will be hydrogens. Then it basically says to me, then what can I do? It means I must just try to make the chain shorter. So if I'm going to make the chain shorter, the first one that I'm going to do is I'm going to say, how about I create now where I have a long chain of 1, 2, 3, 4, and then my carbon number 5 will be this one here. Then I can easily add another hydrogen there, hydrogen here, hydrogen there, hydrogen there. And remember, each carbon must have a maximum of 4 bonds, because you start losing marks if you don't have 4 carbons around, 4 bonds or even hydrogens around each. So let's count the number of hydrogens: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 5 carbons. So it will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So definitely this is an isomer. What will be the name of this compound? The name of this compound will be 1, 2, 3, 4. So my parent name will be a butane. So I will have something like 2-methyl butane. 2-methyl butane. So this here is my branch. Maybe I should also highlight that this is my branch. This is my carbon 1, 2, 3, and 4. So clearly then the IUPAC name, so it means I will get 2 marks for the structure and then 1 mark, then give me 3. There's another option, of course, of making a double branch, which is still allowed, but I always try to get myself an easy way out. So just ensure that you have the correct number of hydrogens, the correct number of carbons, then you should be fine. At 342, how will the vapor pressure of this isomer compare with that of compound P? Choose higher than, lower than, or equals to. What do we know about branches? I must write it here before we can get to the answer. we agreed that now increase in number of branches decreases the strength of intermolecular forces, decreases the strength of intermolecular forces. So if my intermolecular forces are weak, it means I'm going to get low boiling point. So this results in low boiling point, which means high vapor pressure. That is the relationship that we need to understand. So the question is, firstly, understand what factor has been changed. So in this case, the examiner is asking about the number of branches, how the number of branches influence the strength of the intermolecular forces. So once we understand how that is being influenced, it's easy for us to conclude what will happen to the boiling point and easily relate it now to the vapor pressure. So the correct answer in this case should be higher than. So the higher than should be the correct answer. Higher than, and then 1 mark, and then the total thereof, it's now 14 marks. So it was a nice question, but it's a question that wants us now to fully understand what is it that is expected of us. So I'm going to have another question, and then in this question we are going to try and see, now it's another graph, but it's a graph in which I feel that this one, remember, was focusing on chain length. The next one that is coming now is focusing on different functional groups. So we are trying to address another factor in this factor, which is the functional group. So that one, we address the issue of chain length as well as the number of branches. So you don't need to do a lot of problems or questions. You just need to understand fully how each concept is being assessed. So let's look at this one. It was question 6, also a previous question paper. So let's try to analyze fully what is given here. It says the relationship between the boiling point and the number of carbon atoms in a straight chain molecules of alkanes, carboxylic acid, and alcohols is investigated. Already, I can easily say, but now the examiner is asking me about functional group. The reason for that is they have now different homologous series. So once we have different homologous series, definitely I am comparing different functional groups. Remember, why functional groups? Because a functional group is an atom or a bond or a group of atoms that now gives physical and chemical properties of a molecule. Now, define the term boiling point, that is now at 6.1. So at 6.1. But before we get into 6.1, already, is it possible for me to say something about the graph on its own? Yes, I can be able to do so, because now I know that alcohols, carboxylic acid, and alkanes, they have a specific intermolecular forces. So with specific intermolecular forces, I will clear this one because I need now to write here to say I definitely know that alkanes have now London forces. Carboxylic acids, 2 sides of hydrogen bonding, 2 sides of hydrogen bonds. Then alcohols, is just one side of hydrogen bonding. So already, which one is the strongest? It's clear that the one that is very strong, it's a carboxylic acid. Which one can be represented by a carboxylic acid? Already R, it's a carboxylic acid. By just analyzing the information that is given, then it should be followed by the alcohol, which is Q in this case. So Q is an alcohol, and then P, it must be an alkane. So already, even if I don't know the questions that the examiner is going to ask, but I am able to fully explain and interpret the graph the right way it's supposed to be done. So already I have answered majority of the questions here by just analyzing the given graph. What are the questions? The questions are: define the term boiling point. So boiling point, we define it now as the temperature at which the vapor pressure equals the atmospheric pressure. Atmospheric pressure. So it's a definition, like we usually say, is 2 or 0, then you definitely get your 2 marks. Then for curve Q or P, sorry, write down the conclusion that can be drawn from the above results. So in our conclusion, remember, we need to have 2 things that are important. You need to have dependent and independent variable. Dependent and independent variable. So dependent variable in this case is our boiling point. Independent variable, the one that we are able to change, is the chain length, because we are changing the chain length of P. Remember, we are not now comparing R, Q, and P specifically for 6.2. So for 6.2, we are comparing the length of now what? Different alcohols. Different alcohols. So hence it is changing with the number of carbons. So we are not comparing R, Q, and P. Hence the examiner is specific to say for curve P. So what is it that we can say? It's very easy. We can easily see that the boiling point is increasing with the increase in the number of carbons. But now the number of carbons, remember, we relate it now to chain length. So that is the 2 things that we need to understand. So the right way of saying it is that boiling point increases with an increase in chain length. Then you get your 2 marks. How do you get your 2 marks? Remember, in a conclusion, in a your investigation question or investigative question, you should always have your independent and dependent variable, then the relationship between the 2. So in this, we have our boiling point that increases with an increase in chain length. So we'll definitely get our nice 2 marks as well. Very, very important. So if you say boiling point is directly proportional to the chain length, that is not correct, because I did say the increments of how the boiling point does not change necessarily with the same increments as we change the number of carbons. So they are not directly proportional. Hence, we emphasize that let's have a nice relationship between the dependent and now independent variable. So for 6.3, identify the curve PQR that represents the following. This has already been done because we analyzed the graph in detail from the stem that is given. So at 6.31, alkanes must be represented by P, and then at 6.32, carboxylic acids must be represented now by R. Then each one of them is 1 mark. So you'll get 1 mark there, 1 mark, and then you will be happy because you are doing things the right way. Then 6.4. 6.4. Explain the answer to question 6.32 by referring to the type of intermolecular forces present in alkanes, carboxylic acid, and alcohols. That has been done already, because once I saw an alkane, I assigned now the intermolecular force found in alkanes as London forces. And then I found also that because I have a carboxylic acid, I have hydrogen bond, but the emphasis is now 2 sides of a hydrogen bond. So I'm going to explain this because now I'm comparing 3 different organic molecules. So the first thing to do is to explain that compound P, which is alkanes. Okay, so I will say now alkanes have London forces. That is number 1. Then carboxylic acids. Okay, let's go to alcohols. Maybe alcohols have 1 side of hydrogen bonds, and then carboxylic acid has 2 sides of hydrogen bonding. Then what is it that is left? It's me comparing now the strength of the 3. So I will say carboxylic acid has stronger intermolecular forces than alkanes. Okay, the question said I must compare all 3. So stronger EMF than alcohols, but alcohols have stronger intermolecular forces than alkanes, 100%. So I compared now all 3. So what is it that is left? It's me to say something about the energy needed. So the energy needed is more energy is needed. More energy is needed to overcome the intermolecular forces of carboxylic acids than the two other compounds. That is how you get your full 5 marks. Because what did we do? We compared now the type of intermolecular forces found in alkanes. Also, we identified the ones found in alcohol, the one found now in carboxylic acid. We compared the strength of intermolecular forces, then it's another mark, and then we did say something about the energy. So that is how you get your 5 marks. So all these questions, all the concepts, it's easier if one understands exactly how each concept is being assessed and the right way of answering. So if you check with just one simple question, you are able to expand your knowledge and understand concepts fully. So the key idea here was, let's emphasize more on ensuring that we understand the STEM, we understand the information that is given before we can attempt to answer the questions. So the analysis of the graph, the interpretation I did earlier, helped me now to understand each and every set of questions that is being asked. So that was now a problem number 2 of graphs, but generally we are trying to address all other types of questions that you might be exposed to when working with physical and chemical properties. So let's go to the last one. So the last one also was a previous question paper. Hence I said we are going to focus more on the exam type of questions, but now you need to start understanding how we approach these questions, because the approach is very, very important, and the approach should be that we understand the stems or the information that is given. From the information that is given, believe you me, all the concepts will start making sense. Let's look at the information given. It says learners use compound ABC to investigate one of the factors that influences vapor pressure. We did say which factor or how many factors do we have? We have 3 factors. One is chain length. One is the number of branches. The other one we said is the functional group. So with that, already I know what is it that the examiner is going to assess. So if the examiner is going to ask chain length, we agreed that they must belong to the same homologous series and have now different molecular mass or different molecular formula. But now for the number of branches, we said they must be isomers of each other. So they cannot be isomers of each other because now they don't belong to the same homologous series. So definitely the examiner in this case is asking me something related now to the functional group. How can I tell? Because from this information that is given, it's easy for me to say I am looking at an alcohol, I am looking now at a ketone, and then I am looking now at a carboxylic acid. already with this information being said, it allows me now to definitely have a clear indication in terms of the strength of the intermolecular forces. So 311 is that definition of vapor pressure again. So I am not going to do this. You can just go back to the previous question we did. So it keeps on coming over and over again. So it means it's quite important for us to fully understand this definition of vapor pressure. So it's there. Learn it, memorize, and ensure that you understand exactly what this definition exactly means, because the questions will forever change, but they will change in such a way that you apply full understanding of your terms and definitions. Because now majority of us were defining boiling point, but we never understood how to relate a boiling point with the vapor pressure until we addressed this specific problem. So that is how we need now to fully understand the concepts in terms of what is it that is being assessed. So now at 3.2, write down the independent variable for this investigation. So I'll start with 3.2. Independent variable, remember, it's the one that we are able to change. So what is it that is changing? What is changing is the functional group. That is definitely what is changing. Maybe you can also accept if one says it's different homologous series, because the homologous series, it's relative to the functional group. So I believe you can accept that and then get 1 mark. Then we go to 3.2. Okay, that is 3.2. Which compound A or B has a higher vapor pressure? So higher vapor pressure means low boiling point. So what do I need to look for? Weaker intermolecular forces. So between A and B, which one has weaker intermolecular forces? Let me further write here that for B, I have dipole, it's a ketone. So I have dipole, so it's dipole. And then for A, it's an alcohol, so hydrogen bond. Definitely we know hydrogen bonds are stronger than dipole. So at 3.3, then the correct answer should be B. 3.3, the correct answer should be B. And then 1 mark again for that, then 1 mark. 3.4, fully explain the answer to question 3.3. Include the types of intermolecular forces in your explanation. I think that I have already done, because already I identified the type of intermolecular forces found in A, intermolecular forces found in B, then the strength of intermolecular forces. Thereafter, just conclude in terms of the energy needed. So we are going to say now at 3.4, bullet number 1, we say we have compound A. Compound A is an alcohol. It has one side of hydrogen bonding, or we can just say hydrogen bonding. So compound A has hydrogen bonding. Then compound B. Okay, it's A. Compound B has dipole forces. Dipole forces. Then what else do we need to do? Compare the strength of the intermolecular forces. Then we say compound A has stronger intermolecular forces than compound B. Then the last bullet, it's energy. So we must be able to say something about the energy. More energy is needed. More energy is needed to overcome the intermolecular forces of compound A. So all the bullets are there. We identified the type of bonds found in each. Thereafter, we're able to compare the strength. So it will be one for saying hydrogen, one for dipole, one for comparing the strength, and then one now for the energy. That is how you get your 4 marks. The principle will always be the same. If the organic compounds you are referring to or comparing belong to the different homologous series, definitely you need to state the type of intermolecular forces that are found. At the very same time, if the strength, compare the strength and the energy. So this is a standard approach when we are working with explaining in terms of why do we have differences in intermolecular forces. So the key idea will be follow the standard approach that I shared on exam tips, the previous video before this one, part 1 of physical and chemical properties. So by so doing, you will be able to clearly understand what is it that you are doing. But remember, if it's chain length and number of branches, maybe I should highlight here, if it's chain length and number of branches, definitely bullet number 1 should address the nature of the structure. Large surface area, increase in number of branches is things that we'll be looking to see at bullet number 1. Once we are comparing chain length and the number of branches. So with that being said, it allows us to have a clear direction of the explanation that we are going to give. So our explanation will be governed by the factor that is being assessed. So let's first identify and be confident with the factor that we are going to give reasons for. So the fact that I was able to see that, but now the only thing that is changing here is the functional group. It allows me to give correct explanations. So at 3.5, the graph below represents the relationship between vapor pressure and the temperature for a compound A at sea level. X and Y represent different temperatures. Okay, write down the term for the temperature represented by X. So the temperature represented by X, that is 3.51. We know, we agreed that this here, it is our atmospheric pressure. So we said it's the boiling point is the temperature at which the vapor pressure of a substance is equals to the atmospheric pressure. So definitely that should be the boiling point. So you will not fully get this answer correct if you don't understand that definition, that concept of boiling point. Then 352 state the phase of a liquid compound A, or phase of compound A at temperature Y. Choose from gas, liquid, and solid. Now, we know that at this point, what is happening is we start having our compound starts now to boil. So once it starts to boil, it means this section here should represent a liquid. Then once it boils, it changes from a liquid now to a gas. So definitely this region here, the temperature Y, should represent a gas, and then we should be getting our 1 mark. Maybe I should also write it this side for the purpose of full answering of questions. So it must be a gas, and if it's a gas, then we give 1 mark, then that should be correct. So that is how you use the graphs to understand this particular concepts. So I believe moving forward, the issue of graphs will be understood fully, will be understood clearly. So it's what the most of examiners are moving towards, because there's a challenge in interpretation of graphs. So let's do 353. It says redraw the graph above in your answer book. On the same set of axes, sketch a curve that will be obtained for compound C. Clearly label curve A and C. Curve A and C. So now let's start to understand this particular question. We are now comparing A and C. C, which is a carboxylic acid, and A, which is an alcohol. So A being an alcohol, it will have a higher vapor pressure than a carboxylic acid. So this one is an alcohol. How can one explain that? Remember, we said carboxylic acids have now two sides of hydrogen bonding. And having two sides of hydrogen bonding, it makes carboxylic acids to have stronger intermolecular forces. So once we have stronger intermolecular forces, it means we are going to have a higher boiling point. So if you are going to have a higher boiling point, it means your vapor pressure is going to be low. So it means us drawing for C, it must be below A. So I'm just going to try and remove everything just to draw on top of this one. So let's remove this. Then I have space now to redraw C. So for drawing C, what I know is it must now be below A, and then this should be my C. They are not going to have the same point of the boiling point. So it's starting to change, definitely because of the influence of the intermolecular forces. So that will be the 2 marks. What is important here, I think, is that it starts below and now it remains below throughout, because we need to understand that it is now going to have a higher boiling point, which basically means lower vapor pressure. So the temperature here will be high, so the boiling point will be high, but the vapor pressure will be somehow low. So with that being said, I believe we did justice to these questions. So what you need to do now is kindly watch these videos and go back, ask. There's a link now where you can join us in WhatsApp, especially for grade 12. So you can join through the link, then you'll be able to have more of interactive classes with us, because what we intend on doing is we are going to move to a live platform where each and every one of you can be able to ask questions, where you will be able to interact with me. Then I can easily assist and help you with maybe the homeworks that you have, or even the questions that you have, at a certain minimal price, but that will be discussed once you join our WhatsApp group. So from me to you, thank you very much for the support you've been giving us. Thank you very much for watching, as well as don't forget to subscribe and like our channel. Tell a friend, because what we are doing is us trying to ensure that each and every one of us achieves best or maximum marks in physical science. So from me to you, thank you very much and have a lovely day.